Hi kids, so in this video we'll discuss perimeter and area of quadrilateral from class 9 ML Aggarwal exercise 16.2. We have already discussed area of triangles and circle. Now first of all, what is a quadrilateral? A four-sided polygon is known as a quadrilateral, isn't it? What is perimeter? How do you find the perimeter of a quadrilateral? Just sum of all sides, sum of sides. That will give you the perimeter. Now, area. There are different formulas for different types of quadrilateral. We'll see that. First of all, take a simple case. When you have a quadrilateral, suppose this is my quadrilateral A, B, C, D. Now look carefully, if you draw one of the diagonal, BD is the diagonal, then you have divided the entire quadrilateral into two triangles, and the area of two triangles will give you the area of the quadrilateral. If you add the area of the two triangles, we'll get the area of the quadrilateral. Now look carefully. Suppose over here, AM is the altitude or the perpendicular from vertex A to the diagonal BD, and CN is the perpendicular from C on BD, where BD is the diagonal. The area of, look carefully, area of triangle ABD will be half into base, which is BD, into height, which is AM, altitude, and area of triangle BCD similarly will be half into base, which is BD, into AN, isn't it? When you add these two, you get the area of quadrilateral. So area of ABCD will be half into BD into AM plus half into BD into AN, isn't it? Now, if you take half BD common, so that's AM plus AN. So area of a quadrilateral will be equal to half into product of the diagonal, one of the diagonal, and the sum of perpendiculars from the vertex on this diagonal. Am I clear? This is one of the case, okay? Now suppose the diagonals are perpendicular to each other. The diagonals are, suppose I take a case like this and the two diagonals are perpendicular to each other. Then using this concept, can I write area ABCD? Area of ABCD is equal to half into BD. These are perpendiculars, isn't it? Suppose this is M. So AM plus MC, which is half into BD. AM plus MC is AC, which is, if the diagonals are perpendicular to each other, then the area of the quadrilateral can be written as half into product of the diagonals. Am I clear? Now, these are, basic cases, which I've taken over here. Now we'll take the case of some special quadrilateral. How to find the area of certain special quadrilateral? We just need to know the formulas, okay? I'll show you. We'll derive it also. First quadrilateral which we are going to discuss, special type, is our parallelogram. So when you talk about number one, parallelogram. Okay, parallelogram is what? Opposite sides are equal. These two and these two are equal, and they are parallel to each other. Am I clear? So this is A, B, C, D. Suppose from D you drop a perpendicular DM. Then area of ABCD parallelogram will be base on which the perpendicular is dropped, AB, multiplied by the altitude, that is dm, base into height. How come? Very easy. Look over here. If I've divided the entire parallelogram by dotted line into two triangles, ABD and DBC. So area of ABD is half into base into height, which is dm. Yes or no? And area of BDC is half into base, which is DC, into height. Height remains the same, isn't it? Which is dm. Just add these two. So this is half into AB into dm plus half into DC into dm. Now look carefully. DC and AB are equal. So can I write half into AB into dm plus half into AB into dm? These two are same. So half gives you 1. So this will be AB into dm. So area of a parallelogram is base into altitude on that particular base from the vertex. Clear? Sure. This was area of a parallelogram. Second, we will discuss area of a square. Area of square. Now we know square is what? All the sides are equal. This is a parallelogram in which all the sides are equal and all the angles are 90 degree. Okay, and the diagonals are also equal. The diagonals are also equal in this case. Now area of a square, suppose this side is A, B, C, D. So all the sides are A, isn't it? So area will be side square, A square. So if suppose this is 4, then area will be 4 multiplied by 4, or 4 square, that's 16 units square. How come? Same logic. Look over here. If I divide this into two triangles, then area of this triangle will be half into base into height. Area of this triangle is half into base into height. Base, height, base, height. Isn't it? So if you add these two, so half a square gives you a square only. Done. So this is area of a square. Perimeter we know. It's 4 into side. 4 into A. Perimeter in this case will be 4 into A. Done. Now third one will see square. So till now we saw, third one will see rectangle. Till now we've seen parallelogram, which is base into height, and square is side square. Okay. Now let us see the next one, rectangle. Now again, it's a quadrilateral, it's a parallelogram only, in which opposite sides are equal and parallel, and of course all the angles are 90 degree. This is your length, this is your breadth. Okay. Then the area of a rectangle will be length multiplied by breadth, and perimeter will be twice L plus B. How come length into breadth? Very simple. Again, over here, area is what? This is L, this is B. So A1 will be half into base into height. Suppose this is A2. So A2 will be again half into base into height. You add these two. So A1 plus A2 will be the total area of a rectangle, and half LB plus half LB will be LB only. Done. Rectangle. Actually, rectangle has a diagonal also if you look carefully. A, B, C, D. AC is the diagonal. So what will be AC square? Pythagoras theorem. Base square, which is BC square, plus perpendicular square, which is AB square. So AC will be root of BC is what? Length square plus breadth. breadth square. That is your diagonal, root of L square plus B square. So this was rectangle. Now comes rhombus. So what is a rhombus? Again, it's a parallelogram in which all the sides are equal, like square only. But if you look carefully, the diagonals are not equal. The diagonals in square are equal. But over here, the diagonals are not equal. All the sides are equal. This. So suppose you know the base. This is the side. Okay, A, B, C, D. And from here, I draw a perpendicular DM. Then it is a parallelogram. So what will be area? Area will be half into base AB into height DM. This is one of the formula. If you know the base and if you know the altitude from the vertex on that particular base, then half into, sorry, why will I give half? It will be base into height. It will be base into height. So area is base into height, done. But suppose we know the diagonals. This is one of the formula. If you know the diagonals, now in a rhombus, the diagonals are perpendicular to each other. The diagonals are perpendicular to each other. So I've told earlier, half into product of diagonals, D1 into D2. So that is your area. Done? So there are two formulas for rhombus. Half into D1 into D2 or area equals to base into height, because it is a parallelogram. Done? Now next come one more figure we need to discuss, and that's trapezium. So what is a trapezium? We all know. Trapezium is, it's again a quadrilateral in which one pair of opposite sides are parallel and the other pair is not parallel, which means something like this. Look over here, A, B, C, D. These two sides, AB and DC, are parallel to each other, and these two sides are not parallel to each other. The area of the trapezium is half into sum of parallel sides into perpendicular distance between them. Suppose this is A, this is B, and this is H. Okay, AM is H. The area of a trapezium is half into sum of parallel side, which is A plus B, into perpendicular distance between them, which is AM, which is H over here. Done? And if you want to prove this, how this came, very easy. Just look over here. I'll divide ABCD into two triangles, ADC and ABC. I'll just extend this, and from this is your height, H, same. So area of ADC is half into base, which is DC, into height, isn't it? And area of ABC, same, half into base, which is AB, into height, which is H. So if you add these two, half H will be common. So DC plus AB, which are parallel sides. So it will be half into sum of parallel side into perpendicular distance between those two parallel sides. Done? Now let us solve sums from exercise 16.2 from Aggarwal. Now look at sum number 1, part 1. Find the area of a quadrilateral whose one diagonal is 20 cm long and the perpendiculars to this diagonal from other vertices are of length 9 cm and 15 cm. I'll first draw a quadrilateral. Suppose this. Okay, I'll draw this diagonal and the perpendicular from here is this. A, B, C, D. This is M, this is N. BD is given. One of the diagonal is given to us, 20 centimeter. One of the, this is 9 centimeter and this is 15 centimeter. Done. You see, the entire quadrilateral is divided into two triangles ABD, triangle ABD, area will be half into base, which is BD, into height, which is AM. Just substitute the value. Half into BD is known to us 20 and AM is 15. So this is 10. So area will be 150 centimeter square. Then you look at triangle BCD. Same logic. Area is half into base, which is BD, into height, which is CN. So that's half into 20 into 9. That 10 times, that's 90 centimeter square. So area of the quadrilateral will be 150 plus 90. That's 240 centimeter square. Very easy. Or we have done only the formula, that area of this quadrilateral will be half into BD, into product of the sum of two altitudes. You can do like that also. Done. Number 1 part 1. Now look at number 1 part 2. 1 part 2, what they have said. Find the area of the quadrilateral whose diagonals are of length 18 centimeter and 12 centimeter and they intersect each other at right angles. So there is a quadrilateral whose diagonal intersect at 90 degree, okay, perpendicular to each other. And one of the diagonals, suppose A, B, C, D. AC is given as 18 and BD is given as 12 centimeter. We did it in the beginning only. If you have a particular case like this, then area will be half into D1 into D2. Remember, if the diagonals are perpendicular to each other. So just use it. Half into 18 into 12. That's 9 times. That's 108 centimeter square. Simple. Area of a quadrilateral whose diagonals are perpendicular to each other is half into product of the diagonal. Done. Now let us look at sum number 2. Now let us look at number 2. Find the area of the quadrilateral field ABCD whose side AB is 40 meter, BC is 28 meter, CD is 15 meter and AD is 9 meter and angle A is 90 degree. First of all, draw the figure, it will help you. Now this is your A, angle A is 90 degree, that is known to us. AB is 40 meter. AD, somewhere over here, is 9. Made it smaller, okay? 9 meter. Then CD is 15 and AD is 9. BC is 28. So suppose this is your BC. BC is 28 meter and this is my CD, which is 15 meter. Done. Now find the area of this. Look over here. I can divide the entire quadrilateral into two parts, ABD and CBD. If you look carefully, ABD is a right angle triangle. Over there, first of all, find BD, which is the hypotenuse. So BD square, Pythagoras theorem, is AD square plus AB square. Yes or no? So BD square is 81 plus 1600. So BD square is 1681. Am I clear? So what will be my BD? BD will be root of 1681. Okay? Now, if you do it with 41, look over here. 1 ones are 1, 1 fours are 4, 1s are 4, 4 fours are 16. 41. So BD is 41 meter. Square root of 1681 is 41. Done. Now, area of ABD, that's half into base into height, which is 9. So that's 180 meters square. Done. Very easy. Now we need to find the area of BCD. Area of BCD. Now look carefully, this is 41. Now this is a scalene triangle. We know how to find the area of scalene triangle. We have already done. First of all, semi-perimeter, which is S equals to A plus B plus C by 2. Sum of all the sides by 2, which is how much? 40, 50, 60, 70, 80, 84 by 2. Just check it out. 40, 50, 60, 70, 83, 84. Yeah, that's 42. So what will be area? Remember Heron's formula: S minus A, S minus B, S minus C, where A, B and C are the sides. So what is S? 42. 42 minus 41, that's 1. 42 minus 28, that's 14. 42 minus 15, that's how much? 27, isn't it? Because 27 plus 15 is 42. Now find the factors. 42 can I write 2 into 3 into 7. 14 I can write 7 into 2. 27 I can write 9 into 3. How does it helps us? This 2 will come out. This 3 will come out. 7 comes out. And the square root of 9 is 3. Clear? So this is 7 3s are 21 multiplied by 6. That's 126 meters square. So the total area of the quadrilateral will be how much? This plus this, 180 plus 126. That's 306 meters square. And that's the area of the quadrilateral. We divided the quadrilateral into two triangles. One was right angle triangle, half into base into height. The other was scalene triangle. So we use Heron's formula. That we have done this in area of triangles. Sure. We'll do the next sum number 3. Now look at number 3. Find the area of the quadrilateral ABCD whose side, in which angle BCA is 90 degree. Okay. AB is 13 centimeter and ACD is an equilateral triangle of side 12 centimeter. Okay. You need to find the area of ABCD. First of all, draw it. First of all, I'll draw this equilateral triangle. Look carefully. This is my, suppose, ACD. This is my equilateral triangle, ACD. I'll mark A over here, C over here, D over here. Look, it will help us in drawing the diagram, okay? It's an equilateral triangle of side 12 centimeter. An angle BCA, so put B over here. This is 90 degree, BCA, you know, BCA is 90 degree. Okay. AB is 13 centimeter. Done. This is an equilateral triangle, 12, 12. Very easy. Look over here. If you first look at ABC, that triangle, you know, so your hypotenuse, which is opposite to 90 degrees, is 13. Isn't it? So by Pythagoras theorem, can I write AB square is AC square plus BC square? Pythagoras theorem. So that's 13 square is 12 square plus BC square. 169 minus 144. That's 25. So 25 equals to BC square. So BC is 5. Done. And this is your equilateral triangle. Area of ACD. We know how to find the area of ACD. It's an equilateral triangle, root 3 by 4 into side square. We have done this earlier only when we were solving area of triangles. Root 3 by 4 A square, side square. Over here side is, formula kya tha? Root 3 by 4 A square, where A was the side. So that's root 3 by 4, 144. Done. 4, 3 times and 24 for 6 times, that's 36 root 3 centimeter square. Number 2, ABC. Now again, ABC is a right angle triangle. Area of ABC, if you look, half into base. This is your base AC, and height, BC is your height. If you take BC as base, then AC becomes your height. Doesn't matter. Be careful with the hypotenuse. 6 times, that's 30 centimeter square. So total area will be 30 plus 36 root 3. You know the value of root 3, so that's 30 plus 36 into 1.732. Solve it and get the answer. Simple. Clear it? Draw the diagram properly. Sure. Now look at number 4. Now look at number 4. Find the area of the quadrilateral ABCD in which angle B is 90 degree. AB, angle B is 90 degree. AB is 6 centimeter. BC is 8 centimeter. And CD equals to AD is equal to 13 centimeter. This is given to us. First of all, draw something like this. Angle B has to be 90 degree. Then AB is 6 centimeter. And BC was 8. BC is 8 centimeter. CD and AD is 13. CD and AD is 13 centimeter each. Done? Very easy. Look over here. Same. Join this. Area of, first of all, AC is the hypotenuse for this triangle ABC. So we can use Pythagoras theorem. AC square is AB square plus BC square. That is, AC square will be what? AB is 6 square, that's 36, and that's 64, that's 100. So AC will be 10 centimeter. Done? Okay. Now look carefully. Area of ABC. Area of ABC. Half into base into height. Base is BC, height is AB. Right angle triangle. So that's 4 times, that's 24 centimeter square. Done. And then BCD over here. BCD is an isosceles triangle. Beginning. Find the area of isosceles triangle. There was a formula. If you don't know the formula, just look over here. From here, drop a perpendicular. Then the perpendicular from D bisects the base, AC in this case. In an isosceles triangle, if you drop a perpendicular from the vertex to the base, non-equal side, then it bisects the non-equal side, which means this will be 5, this will be 5, this is M. Then look carefully, DMC, that's a right angle triangle. So we can use Pythagoras theorem. DM square plus MC square is equal to DC square. Perpendicular square plus base square equals to hypotenuse square. Hypotenuse is opposite to 90 degree. So DM square plus 5 square equals to 13 square. So DM square is 169 minus 25. That's 144. So DM is 12. Done? Then area of ACD is half into base, which is AC, into height, which is DM in this case, half into base into height. So that's half into 10 into 12 to 1 time to 6 times. That's 60 centimeter square. So total area will be 60 plus 24. That's 84 centimeter square. That's the area of the quadrilateral. दो पार्ट में डिवाइड किया. One was right angle triangle, half into base into height. The other was isosceles triangle. Done? Sure. This was number 4. Let us do number 5. Now look at number 5. The perimeter of a rectangular cardboard is 96. So you have a rectangular cardboard whose perimeter is 96 centimeter. If its breadth is 18 centimeter, find the length and the area of the cardboard. L, this is 18 centimeter. We know this L plus L, that is 2L plus 18 plus 18, that's 36, will be equal to the perimeter twice of L plus B. Very easy, you know. So 2L is 96 minus 36 is 60. So L is 30. This is 30. This is 30 centimeter. Done. Now what? Area is what? Area is length into breadth. Yes or no? That's pretty simple. The 0, 3 8s are 24, 540 centimeter square. And the length is 30 centimeter. Done. Now let us look at number 6 over here only. There's enough space. Let us look number 6. The length of the rectangular hall is 5 meter more than its breadth. So the length is 5 meter more than the breadth. So breadth is x. This is x plus 5. No doubt. The length is 5 meter more. If the area of the hall is 594, area is given as 594 centimeter square. Wait a minute. Meter square. Find the perimeter. Very simple. See, area is equal to length multiplied by breadth. Am I correct or not? Just simplify it. So 594 equals to x square plus 5x. Take it on that side. So 0 equals to x square plus 5x minus 594. Now this we need to simplify by middle term. Factorization. Factors of 594. Just look over here 2. This is 2 times, 2 9 times, 2 7 times. Correct or not? Yeah. This is 3. 3 9 times, 27. 3 9 times. 9 11 times, 11 1 time. Or rather we need 5. 9 3s are 27 and 22. Yeah. So we got it. X square plus 27x minus 22x minus 594 equals to 0. Middle term factorization. We have done this. Okay. Now you take x common. So x plus 27. You take minus 22 common. So x plus 27 equals to 0. Which means x minus 22. X plus 27 equals to 0. Now by 0 product rule we can say this equals to 0 or this equals to 0. So x minus 22 equals to 0, which means x is 22. Or x plus 27 equals to 0, which means x equals to minus 27. Not possible. हो ही नहीं सकता. We just use area equals to length into breadth. We form our equation, quadratic equation, middle term factorization. We got the value of x. So x is 22. So your breadth will be 22 meter and this will be 27 meter. So what will be the perimeter? Perimeter will be twice L plus breadth 2L plus B. Twice bracket L plus B. So that's twice 20, 30, 40, 49. That's how much? 98 meter. And that's your perimeter for this rectangle. Simple tha, we form an equation, solve it, get the value of x and then the perimeter. Chalo. In this video, we'll keep it till here. In the next video, we'll see the rest of the sum. Till then, take care and be safe. And if you like the video, don't forget to subscribe and share with your friends.